Today we are going to begin our adventure in trigonometry, okay? You have been briefed in trigonometry, right? In Algebra 2, you did some trigonometry and even geometry, okay? You have seen radians versus degrees, correct? Okay? You did some right triangle trig, yes?
Is that supposed to be radius?
Yep, supposed to be radius. Thank you. You did some sine, cosine, tangent last year with right triangles. We'll talk about that tomorrow. Okay. So today and tomorrow, we're going to start our trig unit with some familiar topics. Okay. And then when we get into Wednesday, we're really going to get into the meat and potatoes, if you will, of trig. Okay. We're going to have 3 trig chapters. This is the first, and this is the most important. Okay. This will set the tone for the next 2 chapters, but that's what we're getting into. Okay. So, first of all, we measure angles in radians and degrees. Degrees you're most familiar with, radians you've seen, okay? 1 radian is considered to be the measure of the central angle that intercepts an arc that is equal to the radius, okay? So when this arc right here is the same length as the radius, that is considered 1 radian. Okay. So to find a radian measure, we take how long is our arc divided by how long our radius is. Okay. You were told this last year. You probably just forgot it and just remembered how to go from radians to degrees, right? I'm guessing. You can shake your head. Does anybody remember how to go from radians to degrees and back and forth? Something with 180 and pi, right? Okay. Why do we use pi and 180? Okay. Let's talk about converting. Now, we defined a radian, okay, to be the arc length over the radius, correct? So, how many degrees are in a circle? There are 360 degrees in a circle, right? How long is the arc length of that 360 degrees? Well, how do we measure the arc length of the entire circle, also known as the circumference? 2 pi r, right? So this arc length is 2 pi r. Now to find a radian, we take the arc length and divide it by the radius, right? So 360 degrees is the same as 2 pi. Which means, Joey, 180 degrees is the same as pi. Okay, so you are going to use, you guys have all taken chemistry or physics, you have all done unit conversions, correct? Okay, this is just going to be a unit conversion, all right? If we have a degree measure and we want to get it to radians, we're going to multiply by a fraction. What fraction should we multiply this to get it into radians instead of degrees? Okay. If 180 degrees is the same as pi, right? They're the same measure. If we multiply by pi divided by 180 degrees, are we changing the value? Since pi radians and 180 degrees are the same, we're multiplying by 1, right? The degrees cancel, right? And what are we left with? What's 120 pi over 180? Reduced. No calculators needed. 120 over 180. The zeros cancel, right? 12 over 18. What does that reduce to? So we have 2 pi over 3. You have a degree measure. We're going to multiply it by pi times 180. The degrees canceled. We are left with a radian measure. If there is not a degree symbol, I'm assuming it's radians. It is important to put the degree symbol if you're in degrees. Otherwise, we can assume it's radians. Having a pi does not mean radians. Okay? Now, let's go the other way. What if I had the angle measure of 7 pi over 9? How do I get that into degrees? What would we multiply by?
180 over pi.
We're going to multiply by 180 degrees over pi. Okay. Our pi's conveniently cancel. And how many degrees are we working with here? What's 180 divided by 9? What? 20. 20 times 7? Okay, so you will have to do this. You will get pretty good at it. Okay, you'll be able to do it quickly. Eventually, there will be some angle measures where you will just need to know automatically 30 degrees is the same thing as pi over 6. 45 degrees is the same thing as pi over 4. Okay? As we go through the week, there'll be some angle measures that you'll need to know automatically, and we can talk about those on Wednesday. Okay? All right. Arc length. This is something that you talked about last year. Okay? Arc length is just the distance between 2 points on the circumference of a circle. Now, we talked about to find a radian measure, we take the arc length and divide it by its radius. That's how we got our 2 pi radians for our entire circle, our pi radians for half a circle. Okay? So if we just rearrange this equation here, our arc length is just theta times r. Okay? Theta has to be in radians. If your angle is not in radians, you have to convert it. Okay? You need to be comfortable with radians because from here on out, radians is going to be the preferred unit of measure for an angle. Okay? In calculus, almost everything is in radians. Okay? So a majority of our problems will be in radians. So you just need to get used to that. Okay? Our equations, our formulas are going to be, our angles going to need to be in radians. Okay? So get comfortable. Okay? Let's do an example. Okay? I want the length of the arc cut off by a central angle of 30 degrees in a circle with diameter of 3.6 inches. Okay? First of all, what are we finding? Arc length, and what's that formula? S equals theta r. Okay, well, we're looking for S, correct? Okay. What is our angle? 30 degrees, but we cannot put that into our formula, can we? No. So we need it to be in radians. How do we get it to radians? Okay, we want the degrees to be in the denominator of our fraction, so the degrees cancel. 30 degrees is the same as what? Pi over 6 radians. Okay, so our arc length is pi over 6 times, what's our radius? 1.8. Okay, so in your calculators, what is pi over 6 times 1.8? Anybody?
About 49.
And since we are measuring something, we need an angle. Since our radius was in inches, our arc length will be in inches. Easy enough? Okay. Next formula that's very similar along the same lines. We have the area of a sector. Okay, so I'm going to go back to this picture over here. A central angle in our circle. Okay, it's cutting off a piece of the circumference. That's our arc length. If we shade in that piece of pie, basically, we call it a sector. Okay, I want to be able to find the area of a sector, okay, or the piece of pie. So the region in between two radii and the intercepted arc is 1/2 theta r squared. Okay, where once again theta needs to be in radians. Okay, so an example, if the sector formed by a central angle of 15 degrees has an area of pi over 3, find the radius of the circle. Okay, so we're actually given the area, I want to find the radius. Okay. They gave us the area of our sector. What's the formula for the area of a sector? You just wrote it down. Please tell it to me. Thank you. Okay. So we know that our area is pi over 3. And we know that our angle is 15 degrees. We cannot put that angle into our formula because it is not in radians. What would 15 degrees be in radians? Pi over 12. Okay, you can do your conversion, or we just did an example with 30 degrees, didn't we? 30 degrees was the same as what? Pi over 6. We cut 30 degrees in half, we get 15 degrees. We cut pi over 6 in half, we have pi over 12. Okay. All right, so now we need to solve for r. I have pi over 3 equals pi over 24, r squared. When we divide by pi over 24 to get r squared by itself, it's the same thing as doing what? Multiplying by the reciprocal. So when we multiply by 24 over pi, we're left with, which is 8. Okay? And then if we square root both sides, our radius is the square root of 8. Please reduce this to 2 radical 2. Okay? Since we're talking about our radius, this is a length. And so we need to label it in what? Centimeters, since our area was centimeters squared. Those kinds of problems should be the easy portion of your assignment. Okay, you've seen radians and degrees before, you have seen arc length, you have seen area of a sector. Okay, now we gotta get into the fun stuff. Okay, for the rest of the period, we are going to talk about circular velocity. Okay. There are two kinds of circular velocity. First of all, we're talking about speed that involves a circular motion. Okay. So we have linear velocity, the rate at which an object moves forward, and angular velocity, the rate at which an object revolves. Okay, so linear velocity. How fast are we going around? Okay. Angular velocity, how fast are we spinning? Okay. There's a very common, angular velocity and linear velocity can be measured in many different ways, just like any other kind of speed. What angular velocity is measured in your cars on your dashboard?
Please excuse this interruption. This is just a reminder to teachers you are to be handing out the green schedules to students this morning for their new schedules. Also, teachers, there are several of you that did not check your boxes to get those green schedules. Please send someone down to do that. Thank you so much. Bye-bye.
Okay, so in your car, RPM, what does that stand for? Okay, rotations per minute, revolutions per minute, whichever word you prefer, okay? What is that measuring? Okay, isn't it a belt? Some belt. Okay. How many times that belt is going around in a minute, okay? So that's measuring how fast something is spinning. Versus our linear velocity, if we're driving a car, what's our linear velocity? Or how fast are we going forward, okay? So two different types of motion, both involving a circle, okay? Now, if you guys have all taken some sort of physics-y science class, okay? How do we measure distance? What's our famous distance formula involving rate and time? Thank you. Distance equals rate times time. Okay, so everything that we do is still going to be based off of this distance equals rate times time. Okay. All right, so let's talk about linear velocity first. Okay, and I'm going to write up here distance equals rate times time. Okay. The rate at which an object moves forward. Okay. Velocity equals arc length over time. Okay, let's just stop. Okay, don't write anything down right now because I want you to understand where the V, S, and T are coming from. Okay, V is standing for our velocity. right? S, what is S? Arc length, and that's measuring a distance, correct? So if I rearrange this, if I multiply the t over, we still have distance equals rate times time, okay? V, velocity is our rate, our distance is our arc length, okay? Go ahead and write it down now. Okay, we got it? All right, so we have a Ferris wheel, okay? If you are riding a Ferris wheel and you are spinning on the Ferris wheel, you're basically moving along its circumference, correct? So you are traveling a distance, but it doesn't feel like you are because you're just going in a circle, correct? But you're traveling along the circumference over and over and over and over, okay? On a Ferris wheel, we have a rider that's traveling 100 feet in 3 seconds. What's the linear velocity of the rider? Okay. Our velocity is arc length over time, correct? Okay. Our arc length is what? 100 feet. Divided by our time. Okay, so you can say this is 100 thirds feet per second. That sounds funny. What would you probably write? 33.3 repeating feet per second, right? Okay, now feet per second. That doesn't really have much meaning to us, does it? We don't think of speed as feet per second, do we? No. We relate to what? Miles per hour. So let's convert this to miles per hour. This is something you'll need to be able to do. This is something you know how to do. Let me remind you. Okay? So we are going 33.3 feet per second. Since it was written as a fraction here, that's what I'm going to write it as. We are going 100 feet per 3 seconds. Right? Okay, let's remember our conversions. Instead of feet, we want miles. How many feet are in a mile? 5,280. If you did not remember that, write it down. 1 mile is the same as 5,280 feet. Don't forget it. All right? So to get from feet to miles, we're going to multiply by a fraction. I want feet to cancel out, so feet are going to go in the denominator. So we have 5,280 feet is the same as 1 mile. So our feet cancel and we're left with miles. Okay. Now I have seconds, I want hours. How many seconds are in an hour? 3,600. Okay, if you need to go from seconds to minutes and then minutes to hours, that is fine. But there are 3,600 seconds in 1 hour. I'm going to put my seconds in the numerator so they cancel with my seconds in the denominator, and I now have miles over hour. Okay, so now we need to take 100 times 3,600 and divide it by the product of 3 and 5,280. Anybody have something for me? $22.7 miles per hour. How do you feel about that Ferris wheel? I feel like that's fast. I don't know if I would enjoy that up in the air. I don't know. Does that seem fast to anybody else? Okay. No, not fast. I feel like for a Ferris wheel where you're not strapped in, I think that's fast, but maybe I'm a weenie. Okay, you will have to convert to miles per hour again. Please do not forget how to do that. Okay, this is also something that's very important on your big test coming up in April, the NISA. You will have to do conversions on the NISA. Okay, yay, NISA. Okay, angular velocity, the rate at which an object revolves. How fast is it turning? Okay, we've talked about revolutions per minute. That is a type of measure for angular velocity. Okay, right now, this is what we're going to use, and then sometimes we're going to have to convert it. Now, okay, what is that? This is a Greek letter. It looks like a fancy W. Okay, so if you just want to write W, that is fine. Okay, our angular velocity is theta divided by time. Okay, so we're taking how far have we rotated as an angle divided by the time. So our distance is the angle measure instead of the arc length. Okay, that's the only difference. So, if I said that the tip of the spinner rotates 3 pi over 4 in 3 seconds, what is the angular velocity of the tip of the spinner? Okay. Well, angular velocity is measured as theta over time. Okay. Well, if it is rotating 3 pi over 4 radians in 3 seconds, okay, what's 3 pi over 4 divided by 3? How do we do division here? We multiply by the reciprocal. So what is 3 pi over 4 divided by 3? We multiply by the reciprocal, correct? Thank you. Pi over 4. Okay. We have an angle measure in radians over a time in seconds, so we would say this is pi over 4 radians per second. Okay. Okay. Now, all of these examples have been very, very straightforward. Okay. We are going to get into examples that we're going to have to think a little bit. All right. Before we get to those, though, we can measure. Okay, here our example, we measured our velocity in radians per second. I've been talking about this revolutions per minute. We need to be able to convert back and forth between those in order to be able to do some of our problems in tonight's homework. Okay, so let's talk about revolutions per minute versus radians per second. Okay, minutes to seconds, that's an easy conversion. What about a revolution and a radian? How many revolutions per how many radians? Okay, so let's talk about one revolution. One revolution would be the same as how many radians? Okay, 360 degrees, but we need it to be in radians, so 2 pi. One revolution is the same as 2 pi radians. Okay, so that's the conversion that we're going to need. Okay, so I want to go from 10 RPMs and I want to go to radians per second. Okay, so what I want you to do, this is 10 revolutions per minute, so per 1 minute. Do you agree? That's how we would.
Are you doing radians per minute or radians per second?
Oh, it looks like this is radians per minute right there, doesn't it? Thank you. Okay. The angular velocity will measure a lot of different ways. Sometimes it'll be radians per minute, sometimes radians per second. So this says radians per minute. So right now, we don't even have to worry about the minute part of it, right? We can keep the minute part. But I want to go from revolutions to radians. So we're going to multiply by what? We want to cancel out the revolutions, correct? Okay. So one revolution is going to go downstairs so that the revolutions cancel, and then 2 pi is the equivalent, so that would go in the numerator. Okay. So our revolutions cancel, and we're left with 20 pi radians per minute. Now down here, I want to go from radians per second to RPMs. Okay, we're going to go the other way. So if we have 32 pi radians per second, I want to go to revolutions per minute. Which conversion would you like to do first? Seconds. All right. Seconds are going to need to go upstairs, minutes downstairs. How many seconds are in 1 minute? 60. All right. So now our seconds cancel. All right. Now I need to go from radians to revolutions. Okay. So radians is going to need to be downstairs, right? We have 2 pi radians for every 1 revolution. So now we are left with revolutions per minute. Okay. Oh, and look at our pi cancel. So what is 60 times 32? Oh, and then divided by 2. Sorry. So 960 RPM. Okay. It is possible you will have to do one of these conversions to continue to move forward in one of your problems. Okay. So I have 2 examples we're going to look at, and then you have your homework. A phonograph record. What's a phonograph record? Anybody know? Okay, it's a record, and then it has like that big like horn looking thing coming out of it as its speaker. Okay? We all know what a record is, though, right? Okay. So we have a record is turning at 45 RPMs. If the distance from the center of the record to a point on the edge is 3 inches, what did they just give you? Radius. Find the angular and linear velocity in feet per minute of the point. Okay. So if they say angular velocity, they want like radians per minute or radians per second, okay, depending on what unit of measure you were given, all right? So 45 RPM, that is a measure of angular velocity, but they're wanting it in radians instead of revolutions, okay? So the first thing we're going to do is we're just going to have to do a conversion here, right? So we have 45 revolutions per minute. Let's get it to radians per minute. So what should we multiply by? Two pi radians over 1 revolution, so that the revolutions can cancel, and our phonograph is spinning 90 pi radians per minute. Yes.
It was like a test. We have to do all that stuff with your student right now.
My suggestion would be to show the work, because if you mess up on like 45 times 2, you would get the whole thing wrong, even though you did the process right. Okay. I like giving partial credit if you have the right process. Okay, so I do want you to show your work. All right, linear velocity. How do we find linear velocity? S over t. Okay, so what is our arc length? Let's think about something. How do we find arc length? Okay, that was one of the first formulas. Theta r. Okay. Do you see any similarities to theta times r over t? We have a theta over t, correct? What's theta over t? That's our angular velocity, right? So we can also say that linear velocity is angular times the radius. Do you agree? Okay. So instead of finding the arc length, not necessary, we can take our 90 pi radians per minute and we can multiply it by our radius of 3 inches, right? For 270 pi inches per minute. Okay. I would write this down. Velocity is the same thing as WR. Okay. Now, it's asking for the velocity in feet per minute. We just found it in inches per minute. So now we're going to have to go ahead and convert this, right? We have inches per minute. How do we get it into feet per minute? Okay, there are 12 inches for every 1 foot. Inches need to go into the denominator. All right, and please just in your calculator with 270 pi divided by 12. Did you multiply by the pi in there? Okay, last example. A car is moving at a rate of 65 miles per hour and the diameter of the wheel is 2.5 feet. Find the number of revolutions per minute that the wheels are rotating. Okay. How do we do that? Okay. We don't have enough information, do we? If I want RPMs, I need angular velocity, correct? Okay, so find the angular speed of the wheels in radians per minute. We need that first, don't we? Okay, I'm doing this because this happens in your homework, okay? So first of all, let's talk about, okay, 65 miles per hour is giving us what? Is that our angular speed or linear speed? That's our linear speed, okay? So first, this is in feet, this is in miles per hour. It's not really going to help us, is it? Let's go ahead and convert this to feet per minute. 65 miles per hour. right? Let's go to feet per minute. So there are 5,280 feet per 1 mile. And there are hours. There's 1 hour for 60 minutes, right? So we have feet over minute. We have 5,720 feet per minute. Why did I leave it as minutes? We eventually want to get back to revolutions per minute, right? Okay. I want angular speed. We have linear speed. How do we go from linear to angular speed? Okay. We know that linear speed is angular times radius, correct? So if we have a linear speed of 5,720 feet per minute, we don't know our angular speed, but we know our radius is what? Okay, so we can divide by the radius, and we have an angular speed of 4,576 radians per minute. Now we can take this and do our revolutions per minute, can't we? Okay. Since I have to pass up schedules, I am not going to do the revolutions per minute because we've already done a couple of those conversions. Is that okay? All right. Here is your homework. Please make sure on number 101 you have to do part B first. Okay? 101 is set up like the one that we just went through, where they're asking for RPMs, but you have to find the angular velocity first. So do part B first. All right?